Hello students. Now we begin Unit 2, Language Syntax and Semantics. And I want you to feel confident and excited because these are the most important and most predicted questions for your semester examinations. I am guiding you smoothly, clearly, and energetically, just like an experienced lady teacher in a classroom, so that even a 10-year-old learner understands every concept step by step. We start with the question. Define morphology and explain stem and affix classes of morphemes with example. Morphology is the study of the internal structure of words and how words are formed from smaller meaningful units called morphemes. A stem is the core part of a word that carries the main meaning, such as play in playing. An affix is a morpheme added to a stem to modify meaning or grammatical function, such as un or ing. Affixes include prefixes added before the stem and suffixes added after the stem. For example, in the word unhappy, happy is the stem and un is the prefix affix. Now, let us move on to our next important topic, derivational and inflectional morphology. From this topic, we can expect questions such as, explain derivational and inflectional morphology in detail with suitable example. Derivational morphology creates new words by changing the meaning or category of a word, such as adding ness to happy to form happiness. Inflectional morphology changes the grammatical form of a word without changing its core meaning, such as adding s to cat to form cats. Derivational forms often change part of speech, while inflectional forms express tense, number, or comparison. Now, let us move on to our next important topic, morphological parsing using finite state transducers. From this topic, we can expect questions such as, explain morphological parsing using finite state transducers with suitable example. Morphological parsing breaks a word into its morphemes using finite state transducers. A finite state transducer is a machine that reads input symbols and produces output symbols while moving through states. For example, the word playing is analyzed as play plus ing, where the transducer recognizes the stem and suffix through state transitions. This method is efficient for modeling word formation rules. Now, let us move on to our next important topic, parse tree construction. From this topic, we can expect questions such as, derive a top-down depth first left to right parse tree for the given sentence the angry bear chased the frightened little squirrel. To explain the parse tree in words, we start with the sentence symbol, which splits into a noun phrase and a verb phrase. The noun phrase begins with the determiner the, followed by nominal. The nominal contains the adjective angry followed by another nominal, which finally contains the noun bear. The verb phrase starts with the verb chased and then another noun phrase. This second noun phrase again starts with the determiner the, followed by nominal. This nominal includes the adjective frightened, followed by another nominal that includes the adjective little, and finally the noun squirrel. This step-by-step expansion follows grammar rules in a top-down and left-to-right manner. Now, let us move on to our next important topic, probabilistic context-free grammars. From this topic, we can expect questions such as, what is probabilistic context-free grammar? State the benefits of probabilistic parsing. Probabilistic context-free grammar assigns probabilities to grammar rules. These probabilities help choose the most likely parse when multiple parses are possible. The benefit of probabilistic parsing is that it handles ambiguity better by selecting the most probable structure based on language usage patterns. Now, let us move on to our next important topic, context-free grammar. From this topic, we can expect questions such as, explain context-free grammar with suitable example. A context-free grammar defines rules that describe sentence structure. Each rule replaces a symbol with other symbols. For example, a sentence can be replaced by a noun phrase and a verb phrase. Context-free grammar helps represent syntax clearly and forms the basis of parsing in natural language processing. Now, let us move on to our next important topic, statistical parsing techniques. From this topic, we can expect questions such as, explain statistical parsing techniques used in natural language processing. Statistical parsing uses probabilities learned from data to determine sentence structure. These techniques rely on annotated corpora to learn which parse trees are more likely. They improve accuracy compared to rule-only approaches. Now, let us move on to our next important topic, semantic analysis techniques. From this topic, we can expect questions such as, what are different techniques for the semantic analysis for the statement? Semantic analysis techniques include rule-based methods, statistical methods, and knowledge-based methods. These techniques focus on understanding meaning rather than structure by using word meanings, context, and relationships. Now, let us move on to our next important topic, relationships between word meanings. From this topic, we can expect questions such as, explain with suitable examples following relationship between word meanings homonymy, polysemy, synonymy, hyponymy, antonymy, hypernymy, and meronymy. Homonymy refers to words with same form but different meanings, like bank of river and bank of money. Polysemy refers to a word with related meanings, like head of body and head of department. Synonymy means words with similar meanings, like big and large. Hyponymy shows a specific to general relationship, like rose is a type of flower. Antonymy refers to opposite meanings, like hot and cold. Hypernymy is the general term that includes others, like animal for dog. Meronymy shows part-whole relationship, like wheel is part of car. Now, let us move on to our next important topic, WordNet. From this topic, we can expect questions such as, explain WordNet and its role in semantic analysis. WordNet is a lexical database that groups words into sets of synonyms and shows relationships between them. It helps semantic analysis by providing structured meaning relations such as synonymy and hyponymy, enabling machines to understand word meanings better. Now, let us move on to our next important topic, word sense disambiguation. From this topic, we can expect questions such as, what is word sense disambiguation? Explain different approaches used for word sense disambiguation. Word sense disambiguation is the task of identifying the correct meaning of a word based on context. Approaches include knowledge-based methods using dictionaries, supervised learning using labeled data, and unsupervised learning using patterns in text. Now, let us move on to our next important topic, dictionary-based semantic analysis. From this topic, we can expect questions such as, explain dictionary-based approach for semantic analysis with suitable example. Dictionary-based semantic analysis uses definitions and word relations from dictionaries to understand meaning. For example, the meaning of bank is selected based on nearby words like money or river. This approach relies heavily on lexical resources. Now, let us move on to our next important topic, latent semantic analysis. From this topic, we can expect questions such as, explain latent semantic analysis and its applications in natural language processing. Latent semantic analysis is a statistical technique that discovers hidden relationships between words and documents by analyzing large text data. It represents words and documents in a semantic space, allowing similarity detection. Applications include information retrieval, document clustering, and text summarization. With this, students, we complete Unit 2. And if you revise these explanations carefully and confidently, you are fully prepared to score excellent marks and build a strong understanding of language syntax and semantics.